Hi everyone, today we are going to talk about a very important interview preparation question which is trapping rainwater. So this is asked in a lot of interviews and is one of the most favorite question of interviewers. So let's start. So given an array or array list of size n consisting of non-negative integers where each element represents the height of a bar in an elevation map and the width of each bar is 1, determine total amount of water that can be trapped between the bars after it rains. So a little difficult to understand, right? So let's understand it with an example. So let's see what the question says. Question says basically is that we have to find out how many blocks of water can be stored between the buildings when it rains. Okay, so you will be given an array. You will be given an array, and each array element will be considered as the building blocks. So basically, here how many blocks are there? 1, 2, 3, 4, 5. So that means this is a building of 5 blocks. Here we have 1, 2, 3. So building of 3 blocks. Then here we have 1 only. So building of 1 block. Then here we have nothing. So 0 block building. Then 2, then 5, then 0, then 2, then 3, then 1. Now what they want us to do is they want us to find out how much water can be trapped between these buildings. What does that mean? That means how much water, if it rains, can come between these buildings, and we have to answer in terms of blocks only. So let me tell you how. So in this whole building diagram, how much water can be stored? So if we start from here, right, on this building no water can be stored, right? But if we go forward, just a second, let me take blue color to represent water. So now let me consider this as water. Okay, so here on this building there cannot be any water because there is no support to get any water. But on this building, if we come to this building, here you can see we have some space where we can fill water. But are we sure that we have to fill water here? Right? We need support on the right side as well, on the left side as well, and on the right side as well. But we have support, right? For this building, building will help us store water here as well. Why? Because this whole part will be filled with water. We just have to calculate how much water will be there. So on this building, 2 blocks of water. On this building, one, two, three. One, two, three, 4 blocks of water. Here we have one, two, three, 5 blocks of water. Here we have 1, 2, 3 blocks of water. Total blocks of water are 40 in this part only. Now we will come here. Here also we can only fill water here, right? If rain comes, water will be trapped only in this part. 1, 2, 3, 4, right? Nothing on the right side because there is no support on the right side to store water here, right? So 1, 2, 3, 4. So total water will be 14 plus 4, which is 18, right? So total blocks will be 18. Answer is 18 blocks of water can be stored in this. So this way you have to tell, if you are given with this sort of array, you have to imagine that okay, these are the buildings like these, and we have to uh, understand and imagine how much water can be stored there. So we have to write an algorithm for it. Okay, I hope this much is clear. Now let's consider the approach, how we are going to think about it. Basically, that is one thing. So let me remove this. Okay, so now let me tell you how we are going to think about it. So let's come here on the first part, on the first array element, okay, which is 5. So how does it matter? Like the first element never matters in this question. Why? Because this is not going to store any water. On the left side, there is no support. There is never going to be any support. We want for each block, each building, we need support on the left side as well as right side. If you consider a small example, here, if a building of 2 is there and building of 3 is there, right? So in between them, how much water will be stored? Only 2 blocks of water can be stored, right? So this way, if the first building is there, on the left side there is no support, right? So nothing can be stored above it, and on this building as well, nothing can be stored above it. So for the first element, there is going to be nothing. Okay, let me remove this. Now coming to the next element. Tell me, what do you think is the correct algorithm for this? So if you think about it, for a particular building, if you want to see how much water this building can store, we have to basically think about the left side maximum and the right side maximum. What does that mean? That if we are trapped between two buildings, we have to find out what is the maximum building on the left side and what is the maximum building on the right side. That can only help me understand how much water can be stored. So for this building, if you think about it, on the left side, there is 5. 5 is the highest size building, and on the right side, 5 is the highest size building, right? So this is this one I'm talking about. So 5 and 5 on the left side as well, right side as well. So whichever is the minimum. So here 5 and 5 minimum is 5 only, right? So total 5 blocks can be filled here, right? 3 are already filled with the building. So that means 2 blocks of water can come here. 2 blocks of water can come here. Okay, so this is the case. Always think about it as well logically that if you are trapped between two buildings, or two people, let's say one height is small, one height is larger, right? And someone starts putting let's say water onto you. Okay, so your water will start flowing after it reaches the minimum person's height, right? So if let's say you are standing here, you are a person, right? And let's say here is one wall and here is another wall, and someone starts putting water into it. So till here only it will be filled, right? And then it will start overflowing. So this will be considered as the trapped water. Same way, if we have the maximum building on the left side, whatever it is, we will calculate how we will calculate it, I'll tell you. And maximum building on the right side, we have calculated it. So we have to take the minimum of both of them. Right now it is 5 only. And that will tell us how much water can be trapped here. But you are also there, right? You are also there in this, between these walls. So we have to subtract your part as well. That means whatever is the size of the building already there, we have to subtract that. So basically, what does the formula come out to be? That we have to find out the left maximum, we have to find out the right maximum, okay, right maximum of a particular building, whatever is the right max of it. It is not the adjacent building. It can be anywhere, but it should be the right max. Okay. Now, what I have to do is I have to take the minimum of both of them. This is minimum. Sorry, minimum of both of them. And then last thing what I have to do is we have to subtract this part as well, building part. So let's say array of I. I means ith element, basically ith building. Okay, so this is going to be our mantra for each building to calculate how much water is going to be there. Right. So now let's come to this building, second array element, and also it is 9. Sorry for that. So here what we are going to do is on the left side again maximum building is 5 size. On the right side maximum building is 5 size. So what do you think? That again max left max is 5, right max is 5. We have to take the minimum of it. So 5 and 5 minimum is going to be 5 only. Then we have to subtract 1 from it, right? Because building size is 1 only. So 4 blocks of water can come here. 4 blocks. 1, 2, 3. 1, 2, 3, 4. Right? So this is how it is going to work. So now total till now is 2 plus 4. Right? 2 here, 4 here. Now come here. Again on the left side of this 5. On the right side of it 5. 5 is the maximum building size, 5 is the maximum building 5. So minimum of both are 5 only, right? And there is no building here. So 5 minus 0 is going to be 5. So total 5 blocks will come. Okay. 1, 2, 3, 4. Total 5 blocks. So plus 5. Same way as we move forward, we can do it for this as well. 3 blocks are going to be there for this. So total 5 plus 11, 14. Right. Now comes this part here. Now you will see the difference. So for this formula, on the left side for this sixth array element, it is going to be what? On the left side, the max is 5. On the right side, the max is 3. We have to take the minimum of both of them. 5 and 3 minimum is going to be 5 and 3. It is going to be 3 only. Right? Now I have to subtract the blocks. There is no blocks, so 0. So there is going to be 3 blocks of water that will be trapped. Why? And this makes sense as well. On the right side, maximum, if we try to fill more water here, it will start overflowing. This is the trapped water only, right? Now comes this building. Here on the left side, maximum building is 5. On the right side, 3. So 5 and 3, minimum is 3 only. 3 minus 0. 3 minus, sorry, 2 is the size, right? Building size is array number. So that is going to be 1. So that means 1 water can be trapped. Okay. Now coming to this building or this building, what will happen? So for this building, left maximum is 5 and right maximum is 3. For this building, maximum on the right side is 3 only, right? So let me make it clear first and then I hope this much is clear to everyone. Okay. Now coming to these buildings. I haven't taken this building into account, this and this. Other than that, I have taken all into account and total was 18, right? For these and 14. Okay. So now coming to this building and this building. For this building, left max is 5 and right max is actually 3, right? This is the maximum size of building on the right side. So minimum of these are going to be 3. And if I try to subtract 5 from it, it is going to be negative, which is -2. That means if a negative number comes, no water can be stored there. And it makes sense. On the right side, maximum water on this cannot be this part, right? -2. This is there is already building there. So it cannot store any water. Okay. Now coming to this same thing. On the right side, it is going to be 5. On the left side, going to be 5. On the right side is going to be 1. Minimum is going to be 1. 1 minus 3 is going to be -2. This is again a problem. Coming to this part, because let's see this as well. On the left side 3 and on the right side there is nothing, right? So no water can be trapped here. On the last element and the first element, obviously there is no support on the left side and no support on the right side. So no water can be trapped here. Okay. So this is how we are going to solve this question and this is the logic that we are going to take. What is the logic? Simple formula that for each element we have to find this thing. Let me write it here. Minimum of left max building, left side whatever the maximum building is, right max building, right? And we have to subtract array of I from it. This is going to be our method. I hope you got it, right? Now how we are going to write the code, how we are going to calculate it, that is a different thing, but this is the main thing. Brute force approach is simple, that we go on each element, right? We find out the right maximum and we find out the left maximum. For this, we will go on the whole array on the right side, we'll find the maximum building. And on the left side as well, we'll find the maximum building. And then we will calculate it with the help of this formula. So brute force approach is going to take a lot of time and it is going to take big O of n square time. I hope brute force is clear to everyone that we have to go on each element, and for each element we will travel the whole array on the left side and we will travel the whole array on the right side. We'll find the right max, left max for each element, and that is going to take a lot of time, which is going to be big O of n square. We have to jump to a optimized approach. There is another approach that we can use, which is we can store the maximum and the minimum. But that is not the minimum, like maximum from the left side and maximum from the right side. What does that mean? Let's think about this approach. Okay, let me remove this. Let's think about that approach now. Second approach. The second approach is that we have to travel the whole array only once, like twice. Okay, how we are going to do that? So for each element, what do you need? You need the left max and the right max, right? You need left max and the right max. So let's take two arrays, one array and two array. Okay, what we are going to store in these arrays is that we will start from here and we will keep storing the maximum till there. So basically for this array, let's consider, because this is a very big array, let me consider a smaller example. Let's not think about this part for now. Let's say we have only this part. Let's make it simple and easy. Okay, so 0, 1, 2, 3, 4, 5. Okay, same way again, 0, 1, 2, 3, 4. So what is going to happen? What I'm going to do is for each element, I'm going to store maximum till then. So for 0, maximum is going to be 5 only. For 1, maximum is going to be 5 for 3. Whichever is maximum, 5 only. Till 2, maximum is 5 only, because in these 3, maximum is 5. Then we come to third index. So maximum till here is 5. Maximum till here is going to be 5. Then maximum for 5 is 5. So it is going to be 5, 5, 5. Again, if we consider only this part of the array, so let's consider one more. Let's consider sixth as well. Okay, sixth as well. So maximum till there is also going to be 5, right? But when we start, now we are going to start from the left side. We are going to go from left to right. Okay. So for 6, it is going to be 0 only. Now comes 5. It is going to be 5 from a. Now we come to 4. Till 4 from the back side, what is going to be the max? 5. For 3 as well, 5, 5, 5, and 5. So from left to right we are going. We found the maximum till then, right? That is what we need. For each index, we need maximum from the left side, whatever is the maximum till now. And from here as well, we need the same thing, the maximum till here, till this index, from the left to right, from end basically to this index, and from end to this index, we want the maximum that we are storing in these arrays. This is, let's say, left max, and this is right max. Okay, so let's consider this left max and the right max. Okay, so now what we are going to do, we are going to have 5. We already have left max and right max for each index now. Simple. For now what we have to do, now it is very simple. We have to travel our main array which was given to us, which was this. Let's say main array was 5 3 1 0 2 5 0. Let's say this is the main array. So 0 1 2 3 4 5 6. Simply what we have to do is we have to travel this whole array and we have to use that formula. So basically we are going to go on each element. Let's say we are at 5. We start from here. We already have left max and right max for this. So what we are going to do? So let's say uh, left max of I, or let's consider for the 0th element of 0, right max of 0, right? We have to take the minimum of these as we discussed, and then we have to subtract array of 0 from it. Basically I. This is going to be I. We just have to take a loop. So minimum of all those two is going to be 5 and 5, 5 and 5. It is going to be 5 only, and minus array of 0, which is going to be 5. So that means first element is not going to give you any elements, any water blocks, right? So this is going to be 0 for the first element. Then comes 3, then 1, then 0, then 2, then 5, then 0. This is going to be 1 by 1, and we are going to keep adding the elements that will come up into a variable, and that will be the total count of water blocks that are stored. Okay, this is also a good approach, but here we are using extra space, right? So we are using big of n space for storing these elements, and also time complexity is reduced now. It is big of n only. Okay, why? Because we are traveling this array only once, right? There is no double loop or sort of those things. So, but we are going on each element and we are doing some operations and we are doing it only once. That's why the time complexity for this approach is also big of n. So this is a good approach. You can tell it in the interview. Interview will tell you to optimize it more, but this is also considered as a good approach if you know this, right? You can practice it once by yourself, but I'm going to now go to the optimized approach, which is the best approach that you can use. Okay, we are going to talk about the optimized approach in the next video. Till now, write this code only. This last approach that we have taken, try to write the code for this and understand everything. Tomorrow you will get a new video with the optimized approach. Okay, thank you so much.